Now, what we're doing here is adding and subtracting rational expressions with unlike denominators. Now, if the denominators were the same, we could just add the numerators. But because the denominators are not the same, we can't just add. We're actually going to need to make the denominators be the same. Now, the biggest thing with this here is getting them to be the same. And before we can start adding, subtracting, doing any of this here, we need to make sure the denominators are as factored completely, or as factored as far as we can get them. Now, our 9x squared, so just 9x squared. It is one single term. We can't factor it. It is simplified as it gets. 3x squared plus 3x. How can we factor it? It has a greatest common factor of 3x. And we can factor it out of both terms, because if we factor the 3x out of 3x squared, we're left with x. Plus 3x factored out of 3x is 1. Least common denominator and least common multiple, for all intents and purposes, are the same thing. Least common multiple is if we just have two expressions. So if we're just looking at 9x squared and 3x times x plus 1, we would be looking at least common multiple. But because those two expressions are at the bottom of a fraction, we're calling it least common denominator. For all intents and purposes, the same thing. And least common denominator, why we're using it, is we're trying to see what we can need to get these two to be. What is the first expression that these two will be the exact same? And the first thing we're going to look at is, well, our 9x squared and 3x, specifically 9 and 3. So we're looking for the first number that I can turn both 9 and 3 into. And that would be the greatest common factor. And that is because we're going up. Because to get 9 to become 3, we'd have to divide. We'd have to multiply by a fraction. But then we'd be multiplying by 1/3. Because 1/3 times 9 is indeed 3. But if we do that, we're now turning a fraction into fractions. We have more fractions. So we're trying to go up. Nope, 9. Mm-hmm. We don't have to change both of them because, again, when we did least common denominator yesterday, we looked at the factors of each term. Well, 9 as a prime factorization is 3 and 3. Because we don't use 1 because 1 with prime factorization just makes things a little messy. In that, we could say it's 1 times 3 squared. Because 1 times 3 squared is 9, yes? Well, 1 squared times 3 squared is still 9. 1 to the 12th times 3 squared is still 9. So 1 with prime factorization doesn't help. It actually just makes things a little too complicated because we're just looking at the prime factors other than 1 of this here. And, well, technically 1's not prime. But that's a side fact. We don't have to worry about it. Because when we break these down to the prime factorization, we're looking for which one has the most of each term. 9 has 3 squared. 3 is just, well, 3. So which one has the most 3's? 3 squared. So we'll need 3 squared. Well, 3 squared is 9. Now we can look at the x's. One of them has x squared, the other has. So we need the x squared term. Because again, we're trying to get them to be the same. And really just looking at this so far, if I want to turn the 3x into 9x squared, what do I need to multiply the 3 by? Yeah, 3 times 3 is 9. They're the same. X, I need to be x squared. I need to multiply by x. Because if we multiply the 3x by 3x, we get 9x squared, yes? Those are the same. Over here, we've now made the 9x squared and 3x. Those are the same with multiplying the 3x by 3x, yes? What is the left-hand side missing that the right side has. So I would need to also multiply it by x plus 1, because if we do this, the right-hand side, sorry, left-hand, 9x squared times x plus 1 is 9x squared times x plus 1. We're not going to distribute with denominators. We're not going to distribute through. And I'll explain and point it out here in a little bit. On the other hand, 3x times 3x. So we're not multiplying through. We're just in the front. Our 3x times 3x is 9x squared times our x plus 1. Questions on this here? Now we've gotten the denominators to be the same. And it works out that the least common denominator is this 9x squared times x plus 1. That's the goal of getting the least common denominator, is just seeing what is going to make the two denominators be the same. And what they're going to be is 9x squared times x plus 1. It's going to be that least common denominator. So the least common denominator, for all intents and purposes, is just helping us get what the denominator is going to be the same. That's all it is for. Now, any questions on how we got the denominators to be the same? We good with this so far? Yes? Now, we can't just multiply the denominator on the left by x plus 1. We also have to multiply the numerator. We have to do top and bottom. Because x plus 1 divided by x plus 1, anything divided by itself is 1. So we're really multiplying the left-hand side by a fancy version of 1. The right-hand side, we're going to have to multiply the numerator by 3x, because 3x over 3x. So when we do this multiplication on top, we are going to be multiplying the 7 by the x plus 1, and our 3x by our x. Interestingly enough, we're not going to have to distribute through the denominator. We're not going to have to multiply the 9x squared by our x and our 9x squared by 1. Because when we add two fractions, when the denominators are the same, we add or subtract the numerators, yes? So here, even though, well, since they are like terms, it just stays 9x squared times x plus 1. Because when we add two fractions, we looked at this the other day, say 2/4, well, not 2/4, let's say, well, the reason I say that because that reduces, let's just say 3/4 plus 1/4. Denominators are the same, we can add them, we're doing 3 plus 1. We still have the 4 on the denominator. We're not having to combine like terms. We're not having to do any addition and subtraction with it. So there's no reason to factor. The numerator, we will have to combine like terms. Just like with our 3 and 1, we had to combine them. We have to combine the like terms. And we can't combine them if they're in factored form. So what we have to do is distribute. Our 7 times x is 7x. 7 times 1 is 7. The other side, 3x times x is 3x squared. Questions on this here? Questions on anything we've done so far? Now at this point here, since the denominators are the same, we can add the numerators. Now, since we're adding, we really don't need the parentheses around it, because again, we don't have a sign change, unlike with subtraction. So we could have just said that it was 7x plus 7 plus 3x squared. Now I'm going to rewrite it in standard form, 3x squared plus 7x plus 7. But any questions on any of this here? Any questions on any of this so far? But the big thing with this is getting the denominators to be the same. And to get that, we need to factor. Because once we factor them down, we see what we need to do and simplify from there. Questions on this here? Okay. Now, before we say we're done, we need to make sure that 3x squared plus 7x plus 7 is, well, we need to see if it's factorable, because if it is, we need to factor it. If it's not, we can leave it as is. And the reason for that is because if 3x squared plus 7x plus 7 does factor and we get an x plus 1, the x plus 1 over x plus 1 would simplify. Now, we can't simplify our 3x squared and 9x squared because our 3x squared plus 7x plus 7, that is one term. It's all combined. Or, well, not one term, one expression, to be technical. So we can't just cross those out. We can, but it's not going to make it simpler. So, now if we want to check and make sure, because it looks like this may or may not, and it is a quadratic. I think y'all remember our square root of b squared minus 4ac, yes? This, the only purpose for this here is just to see if it factors. Our b in this case is 7. Our a is 3, and our c is 7. Now if this here gives us a integer, 7 squared minus 4 times 3 times 7 gives us a domain error, which means whatever's inside the radical is negative. So domain error, this doesn't work. It tells us that 3x squared plus 7x plus 7 is not factorable. So that means we can't simplify this down any further from this here. The only way we can simplify it down is breaking it into parts, but that's not really simpler. This is the final answer. Questions on this here? Questions on any of this so far? We good with this so far? Yes? All right. Is anybody still writing? Yes? No? We're good? Okay. Find the sum of 8 over 12x squared plus x over x squared plus x. Again, we need to factor the denominators. We need to factor the denominators first. 12x squared, well, that's as simplified as it gets. X squared plus x, can we factor it? It has the greatest common factor of x. So we can factor in x out of both x squared and x, yes? If I factor an x out of x squared, we're left with plus 1. Whenever it's just a single term, it's simplified as it gets. When we just have one term, just 12x squared. X squared plus x. We don't have 3. Be looking for greatest common factor, because most likely that's all there's going to be. Okay. Questions on this here? Now we do need to, for most part, find the least common denominator, see what's going to make them be equal and go from there. Let's come at it a different way. Hopefully a way that'll make this a little bit easier to work. I'm going to look at the right side first. Yeah. X times x plus 1 is what we have on the right, yes? What does the left have that that one doesn't? Okay. So let's start over here. 12x squared. What does the other side have? Well, the other side has x and x plus 1, yes? But we have an x squared already, so that's more or less covered, yes? X and x squared. Well, we can go up, we can't go down. So all it's missing is what? Really the x plus 1, yes? So we need to multiply it by x plus 1 to get them to be the same, yes? Let's go the other direction. What does our x times x plus 1 not have that the other side does? Because we need the 12, yes? But it also has an x squared, yes? It has an extra x. We have an x, but we need it to be x squared, yes? Because x squared is x times x. Because we have two x's being multiplied together. For over here, this one over here is just x to the first. So to get it to be x squared, we have to multiply it by another x. Questions on this here? I think we like this way a little bit better, yes? Because a lot of this is just looking at and seeing what we get. Because if we multiply the first one, 12x squared times x plus 1, we just get 12x squared times x plus 1. If we do the other side, our x times 12x is 12x squared times x plus 1. So if we did go and find the least common denominator, it actually works out to be 12x squared times x plus 1. Because the least common denominator is just what's going to make these two denominators be the same. What is the first expression that will make them be the same? Well, it is 12x squared times x plus 1. We can look at the two denominators and see what does one have that the other doesn't. What is it missing? And we can multiply it by it to get there. Questions on this here? Well, we also have to multiply the numerator by x plus 1 on the left and 12x on the right. Eight times x is 8x. 8 times 1 is 8. X times 12x is 12x squared. Since the denominators are the same, we can add the numerators. Now, since we're adding, we really don't need the parentheses. We put the parentheses, especially with subtraction, to make sure we get our signs correct. Because we have to distribute that negative. That's what causes issues. Because there's nothing wrong with putting the parentheses around it. But when we rewrite it, the first set of parentheses is going to go away. And the second set of parentheses will go away, and we get back to 8x plus 8 plus 12x squared. So we don't get anywhere with it, really. Does that make sense? Because the time that we're really going to focus on it, when this is not plus, it is minus. Because when it's minus, we have to distribute that negative to every term in the second numerator. And we'll do one of those in a minute. Let's write in standard form. Questions on any of this so far, how we got to this point? Now at this point here, we do need to see if we can factor the numerator in any way, shape, or form. Is there any way that we can factor our 12x squared plus 8x plus 8? 4. There's a greatest common factor of 4 that we can factor out, which will turn our 12x squared into 3x squared, our 8x into 2x, and our 8 into 2. Now we can look at 3x squared plus 2x plus 2 and try to see if it factors. It doesn't seem like it will. So we can check it. 2 squared minus, I'll have to get that back in a minute, 4 times 3 times 2. We can plug in the calculator second, square root. Squared minus 4 times 3 times 2. Well, it's another domain error. Not factorable. So 3x squared plus 2x plus 2 does not factor any farther than that. Just testing to see, will it factor? And the reason I do that is because if I look at it 3x squared plus 2x plus 2, I have a feeling it probably won't. Instead of doing our 2 sets of parentheses with 3 spaces. Third term's positive, so signs are the same and match the sign of the middle term. Going through the entire process with factoring and trying to test and see if it works, well, this already told me it's not factorable. I don't even have to do the setup. I don't have to do any of the steps because I know immediately it's not going to factor. Does that make sense? Because we could go through this setup and see 3x times 2 is 6x. 1 times x is plus x, giving us 7x. Not the middle term we wanted. I can switch the 1 and 2. 3x times 1 is 3x. 2 times x is plus 2x, giving us 5x. So the only 2 arrangements that we have, neither one of them works. But our b square root of b squared minus 4ac told us that from the beginning. Does that make sense? So it's a way to skip having to check all of those steps. But looking back at this here, do we now have something in common on top and bottom? Factor of 4, yes? 4 and 12. The 4 in the numerator will reduce out. The 12 on bottom will become 3. Now we couldn't reduce it in the step before getting our 4 factored out, the 12x and 12x squared, because the 12x squared on top is being added to 2 other terms. We can't use our addition subtraction. But because of the multiplication, we can do the simplifying here of 4 over 12. The multiplication is what changes it, and we can actually simplify. Questions on this here? Questions on anything we've done so far? We ready for the next one? Yeah. Well, I do not want to write in a highlighter. First thing we need to do is factor the 2 denominators. The one on the left, we have 2x minus 2. How can we factor it? Denominator. The 2. We have a greatest common factor of 2. Which will leave us with x minus 1. Now the numerators, we're going to leave them alone. Even if they are factorable, we're going to leave them alone because, as we've seen in the last few, we haven't had common factors so far, but if there are, we have to add or subtract them together. We have to combine them. So there's not a whole lot of reason to factor it if we have to undo it to be able to combine like terms. So the denominators are the only things we're going to factor. So our 2x minus 2 has a greatest common factor of 2. Is there a greatest common factor between our x squared, 4x, and 3? No. And since we do have 3 terms, there's a good chance we can factor it with 2 sets of parentheses. Since our third term is positive, our signs are the same and match the sign of the middle term. Minus and minus. Factors of x squared. X and x. Factors of 3 are indeed 1 and 3. If we did want to make sure, I can do it off to the side. X times negative 3 is negative 3x. Negative 1 times x is negative x, giving us negative 4x, which is our middle term. So that's just verifying. Okay. Now we can see that the denominators of these two rational expressions are indeed not the same. Now the denominator on the right are 2 times x minus 1. Well, what is it missing that the one on the left has? X minus 3. Because for them to be the same, the one on the left needs an x minus 3, yes? So top and bottom, we need to multiply it by x minus 3. Does it have anything else that the one on the left needs? The other side, yes. The one on the right needs a 2. They both have an x minus 1, yes? So that's covered. That's already the same. We don't have to do anything with it. So the only thing the one on the left is missing is an x minus 3. The one on the right is just missing a 2. Now, if we went and found the least common denominator, well, 2 would be involved. We'd have an x minus 1 and an x minus 3. This is what the least common denominator would be. But we can find it also this way here. Because if we multiply these out, we'd have 2 times x minus 1 times x minus 3. The other would be 2 times x minus 1 times x minus 3. Our numerators, we are going to multiply our x minus 3 and x plus 2 together. And the other we're going to multiply with 2. Now it is possible to do this multiplication without having to rewrite it, but in some cases it is nicer, or we can keep everything a little bit more organized if we write it out first before we start multiplying everything together. We can start on the left-hand side. We're going to distribute. We're going to do x times x, which is x squared. X times 2 is plus 2x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. So we will have to combine some like terms there. The other side is a little bit nicer. 2 times negative 2x. Negative 4x. 2 times negative 1. Negative 2. Numerator on the left-hand side, our x squared plus 2x minus 3x minus 6 has like terms, yes? 2x and negative 3x. Well, 2x minus 3x is negative x. Our negative 4x minus 2 is just negative 4x minus 2. There are no like terms there. Questions on this here? Questions on any of this so far? We good up to this point? Yes? Now, since the denominators are the same, we can subtract. We can subtract our numerators, yes? Now, since we are doing subtraction, I would highly encourage y'all to actually use parentheses for this here. Subtraction, it is very important to use parentheses. Addition, it's neither here nor there. Because with a plus sign, well, as we had on the previous one, plus 12x squared, if I have the parentheses or not, is still positive 12x squared. Because when I subtract, because if I subtract a negative 4, when I subtract a negative, the negative and negative make it positive 4x. And when I subtract my negative 2, it makes it positive 2.
Are you just doing that for example, or is that actually how it is?
That's actually how it is.
Okay. That's, I guess, for a line. I didn't know.
Because, again, we have to distribute that negative through the second numerator. That's why it's important to put that parentheses, that we don't just apply that negative to the first term, but we have to apply it to every term. Question. I applied this negative to both the 4x and 2 because we're subtracting our negative 4x and we're subtracting our 2. Yep. Yeah, so we're applying it to both. So that's why it's important, especially on subtraction, to put those parentheses. But addition, we don't need it because the addition sign is not changing a sign. Subtraction is. And the denominator is still going to be this here. Now, for the first time today, we actually do have some like terms. Our x squared does not, so it's just x squared. But our negative x and 4x, negative x plus 4x is plus 3x. Negative 6 plus 2 is negative 4. Questions on how we got to this point? Hang on for this one. If they get mad, tell them to call me. Yeah, we're almost done. Yep. Well, we can do our b squared minus 4ac. Because up to this point, none of the ones, the numerators have factored, so let's go on and check it just to make sure. Let's see. Because it was 3 squared minus 4 times 1 times negative 4, and just like the previous ones, we get either domain error or a decimal number, yes? So we just get 5, yes? No decimal, which means that factors. Because if we get a whole number, a number without a decimal, all that's telling us is that x squared plus 3x minus 4 is factorable. Now, it's not going to be 5, because the 5 is just telling us that our x squared plus 3x minus 4 will factor. Now, since there's not a greatest common factor, we're not going to pull something out. But we'll still have our 2 sets of parentheses with 3 spaces. Since the 4 is negative, our signs are opposite. Factors of x squared. X and x. Our factors of 4 are 4 and 1 or 2 and 2. Which one do we want to use? 4 and 1. Put the 4 with the plus, 1 with the minus. Because if we put the 1 with the minus, we now have an x minus 1 on top and bottom. So if these are the factors, we will have something that reduces. And if we check to make sure, x times negative 1 would be negative x. 4 times x would be plus 4x, giving us a positive 3x, the middle term we wanted. So there is something in common on top and bottom, yes? So those would cancel, leaving us with over. And since there's nothing left in common on top and bottom, that is good. Yes.